Good day to everyone. So today we are going to talk about how to solve equations in main properties. So the first thing to pay attention to is what is an equation first. Okay. So the equation, it's the equality that has unknown quantities in some two sides. Okay. So you don't have to mix between an equation, which is something like this, right? And what we call an algebraic expression. Okay, so let's say 2x plus 3 is just an expression, it's not an equation. Okay, but this is very important. It's about the terminology. You have to understand what you are talking about. So solving an equation, it comes to find the values of the unknowns that satisfy that equation. So let's say if I solve in R, the equation 2x plus 1, 2x minus 1, so equal to 0, right? So it means I have to find the real numbers such that 2 times my real number minus 1 equal to 0. So usually to solve this kind of equation, we have to make use of some basic properties, right? So I can add 1 both sides. So I get 2x minus 1 plus 1 equal 0 plus 1, right? So to get rid of the negative 1, then I get 2x equal to 1, right? Then, because then I can divide both sides by the same number, it means that I multiply both sides by half, okay? Then I would get x equal to half. So this is the answer of this, right? So usually we would skip this, we don't write it down, and we would skip this one as well. We would never write it down in our steps. So you can do that mentally, you aren't required to do that. So the solution of the equation 2x minus 1 equal to 0 in R is half. So this is the solution in R. Okay, remember R is the biggest possible set for us. So now if I try to solve the same problem, but not in R, but in the set of natural numbers, I'm going to start the same way, but the only thing I would be not having these two steps, okay? Because there is no natural number. This implies that x belongs to empty set. I cannot imagine a natural number such that 2 times my natural number is 1, because 2 times a natural number is an even number, right? So 2 times any natural number would give me an even number. So 2 times a natural number would never be equal to an odd number. So this is even and this is odd. So this equality is impossible, right? That's why we write x belongs to empty sets, right? So we say that this equation here has no solution. Okay, so the equation, would say that the equation 2x minus 1 equal to 0 has no solutions in the set of natural numbers. Okay, so remember, so this is even, this is odd. Okay, there's no such thing that an even number could be equal to an odd number. Okay, so this is just an introduction. Now we have our first theorem, which is given by this rule actually. So the product of two factors is equal to 0 if and only if one of the two factors is equal to 0. It means that if I have a times b equal to 0, this is to say that either a equal to 0 or b equal to 0. again, we are talking here about two factors. When we write A, we may mean some expression actually, right? A times B. Let's say I have x minus 1 times x plus 2. So this is equal to 0, right? So in my example here, x minus 1 is my A, let's say, and x plus 2 is my B. So how to solve this kind of equation? My rule tells me this is equivalent to say that A equal to 0 or B equal to 0. So solving, this is going to say that x minus 1 equal to 0 or x plus 2 equal to 0. And this is equivalent to say that x equal to 1 or x equal to negative 2. It means that I have two possibilities for this side to be equal to 0. Okay, for this equation to be true, to be satisfied. Okay. So this is the first rule. So again, A and B, they might be some A and B here, right? They can be simple variables or represent expressions which are valid for any possible values of R or valid for some, if we have some extra condition, maybe we'll see that afterwards. Okay, so for the second property, so this is number 1, this is number 2, this is number 3. So if I have A over B equal to 0, this comes to say that A equal to 0 and B is equal to 0. Right. So actually A over B, I can rewrite it as A times 1 over B. Okay. So if I rewrite it this way, then I'm going to use the first property to answer my question. Okay. Now, we know that 1 over something is never 0. Okay. 1 over something is never 0. This is the idea now. So if A times B, A times 1 over B is equal to 0, so A times 1 over B equal to 0. If I use property number 1, I get A equal to 0 or 1 over B equal to 0. So 1 over B is never 0, but there is a condition here. Remember here? So if I have any condition. So 1 over B, for this to be existing, B has to be different of 0. Otherwise, this patent has no meaning at all, right? So there is a condition that we have to put here. So, and B different of 0. Okay. So this is going to say that A equal to 0 or X, the unknown in definition B is X, right? So this, since this is possible, it means that X belongs to empty set. Okay. And B is different of 0. So if I have a set union empty set is the other set, so whatever is the set of solutions of this equation, I'm going to get this at the end. So this is where this property comes from. It's like from the first one actually, but by understanding our factors, what are they, what are the conditions on them. Okay, so this is for the second property. Okay, so now I'm going to erase this, right? Okay, we understand what does come from the condition B different of 0 in second property. Okay, now we go to the third property. For the third property, so I have A times B equal to A times C. How to solve this one? Some students, what they do, they will just go and cancel, what they call it, cancel the A, and they say this comes to say that B equal to C, which is completely wrong. Do not do this mistake. So there's no such thing in mathematics which is called cancel. Okay, so in mathematics, either we multiply, we divide, we do the addition, we do the subtraction. These are the operations that we have. We don't have an operation called cancel. Okay, so if you want to deal, so what you mean by, usually what students mean by cancel is just like they take all of this and divide by A. This comes to say that A times B divided by A is equal to A times C divided by A. Then they simplify A with A over A equal to 1. But this is not true. Okay, A over A equal to 1 if A is different of 0. So this is the mistake. Okay, this is why so many students do this mistake. They don't have in mind that A over A is not always 1. Okay, so if I try to do the things in a proper way, times C 0, I factorize A, I got A times B minus C equal to 0. I apply the first property again, I get A equal to 0 or B minus C equal to 0. Then I get either A equal to 0 or B equal to 0. Okay, so this is it. So I can write my property now is A times B equals A times C. This is comes to say A equal to 0 or B equal to C. Now, if I know that A is never 0, then it's much more easy, right? Okay, I can divide by A, then I go. Okay, but this is when I know I have no idea what is A and B. Could they be 0 or no, right? So do not jump. And okay, so if A is different of 0, then this one would give me A 0 would give me empty set, X belongs to empty set. So there would be no problem at all. So just use the property. So this is the property number 3. So when I use this property, you understand them now in different situations and solve the given examples here. So I'm just going to take, let's say, number 3, example number 3, example 3, right? Example 3, we solve x squared plus 1 over x plus 5 equals 0 in R, right? So if I look at it, I can say that it has this equation has no solution actually. But if I go and apply my properties, this comes to say that x squared plus 1 equals 0 and x plus 5 equals 0. This comes to say, so here that x belongs to empty set and x different of negative 5, because x squared plus 1 cannot be 0. This is impossible. So this is comes to say that x belongs to empty set. It means that this equation has no solution. So the equation has no solutions. Okay. Now, if I take something similar, but instead of having no solution, I would pick one special example, just explain the property, the same property again. Just a tricky question. So let's say we have here x squared minus 1 over x plus 1 equal to 0. If I don't pay it, so I have x squared minus 1 over x plus 1 equal to 0. This is comes to say, well, x squared minus 1 equal to 0 and x plus 1 equal to 0. This is comes to say, if I factorize this, I know that if I have a squared minus b squared, this is a minus b times a plus b. Identities, right? So this is x minus 1 times x plus 1 equals 0 and x different of negative 1. Okay, which is going to say that I use the property number 1, right? Or x plus 1 equals 0. So we do not miss the brackets, you must put them here. And x different of negative 1. This comes to say that x equal to 1 or x equal to negative 1 and x different of negative 1. So this is going to say that x belongs to this set and X belongs to R except -1. So this is comes to say that X belongs to this set only, if I do the intersection between the two sets. So that's why these brackets here are very important, not to miss. That's all. So this is my set of solution. But if someone do the mistake and look only at the top, and he or she would miss this condition here, the answer would be this one only, which is completely wrong. Okay, so be careful to the property when you apply your properties. So here the solution is X equal to 1. So we have only one possible solution for this equation. Okay, so that's all for this video. Thank you for watching.